This video shows you how to find derivatives algebraically. Alrighty, so there's our generic formula. Most of this formula is what is called the difference quotient, which is right out of algebra. The calculus part is the limit, and then the fact that we actually call that the derivative. And you can see the notation there, that prime symbol, the apostrophe, right there is how we notate one of the ways we notate the derivative. So I'm going to walk through how to find the derivative here using the difference quotient. So the first part is to take the original function and evaluate it with the z plus h, whatever the independent variable is, you change it. It was x before, now it's z. So we put it in both places where the z is in this particular one. And then the first one is squared. So I've written that out in several steps. So let's walk through the lines. So I've just substituted the z plus h in the first line. I've expanded the square right there. I've distributed that minus 2. And in squaring it, I'm taking some small steps. So I've taken the z from the first parentheses and written it down and multiplied it by the second parentheses. I've taken the h from the first parentheses and written it down and multiplied it by that second parentheses. All the stuff on the outside of the square brackets, nothing has changed. We took care of that in the second step. So inside the square brackets, I distribute the z squared and z plus h. I distribute the h, another zh plus an h squared. I combine like terms in the next step. There are 2 of the z times h's. And in the last step, I distribute that negative 3. So that's g evaluated with z plus h, that line at the bottom there. Step 2, g of z plus h minus g of z. So I take the answer from step 1 and subtract the original function we started with. So with that original function, I'm going to distribute the negative sign. The signs change, and I look for like terms. So the z squareds are alike, they cancel out. The z's are alike, they cancel out. The 5s are alike, they cancel out. So we're left with that. And then the third step of the difference quotient, we take that answer and divide by h. So I wrote that down with a divide by h. I factored an h out of the numerator, and then h divided by h cancels, and we're left over negative 6z minus 3h minus 2. The calculus part for the derivative is we take that answer and we figure out what happens as h approaches 0. That's the limit that we're doing there. So when h approaches 0, that term just goes away. And we're left with negative 6z minus 2 being the derivative of that quadratic we started with. Next example is just evaluating that derivative. So I just plug a 2 into that equation and do some arithmetic, get negative 14. And the last part, we're going to find the equation of the tangent line at the indicated value. So we are using z equals 2. Step 1, evaluate the original function to find the y value that goes with that x value of 2. So the original function, plug a 2 into it, we get a y value of negative 21. Step 2, that was the example 1, find the derivative. We've done that. Step 3 was evaluate the derivative with the x value. That was example 2. That's what we call the slope of the tangent line. You can see I did that right there. Well, I rewrote it. That's where I did it, example 2 there. And the last part, the equation of the actual tangent line, there's the generic form. The m is the slope you calculated. The x1 is the value you're given. The y1 is the y value you calculated. And I just dropped those 3 things in there. You can distribute and combine like terms if you want to. I don't require it for this class.